Discuss this question from LeetCoding challenge. Problem 8. Valid perfect square. Given a positive integer nums, write a function which returns true if nums is a perfect square, else return false. And note, do not use any built-in library function such as std. So as you can see in this input, 16 is a perfect square, which is 4 into 4, but 4 is not a perfect square, so you return false. Okay. The main trick in this question is, can we do a brute force method? The first thing comes to mind comes to my mind is, can I do brute force? But for brute force, we have to know the input size or some constraints, but there are no constraints given. But if you look more carefully in the question, they have given that the input is of nums, which is an int data type, which means the size can be up to 10 to the power 9. If we take a like upper bound, it will be equal to 10 to the power 10, and if we do a square of it, so if we take 10 to the power 10 for int, if we do a square of it, square root, it 10 to the power 5, and that can easily be done by a brute force, because you can easily do 10 to the power 6 computation in a second. Okay, so now we can do a brute force method. We can easily see. So because it is a perfect positive integer, so we don't need to check for the boundary cases of negative or 0 or something like that. So you can easily go through that. But the main thing which appears here is I into I is equal to nums, which is the input. If we go for every I, multiply them and check whether this is equal to nums, that can also be done, but can we reduce just a little bit our time complexity? Okay, as I and I are both numbers, and when we multiply them it's equal to num, both of them should divide nums, which means, as you can see, 4 into 4 is equal to 16. So it means 16 can be divided by 4. I hope this is simple logic sense. So this can be useful for us. So also, to not go out of bound, what we'll do is, we'll take int to be long. I'll tell you why I use this. I is equal to 1. We'll do a loop from I, and we'll do I into I less than equal to num, I plus plus. Why we use this? Because we can either do under root of nums, I is less than equal to under root of nums, but then we are using this function and I don't want to use this function, so I have multiplied I into I. But if I put I to be integer, then I into I can cause an overflow. I hope you understand, because I can get to an integer, and if we make the integer size so long such that if we do multiply two integers, such that integer can store 10 to the power 5 size, and if we do 10 to the power 5 and 10 to the power 5, this number will become 10 to the power 10, which we cannot store in integer. So this condition will give an overflow. So that's why we use long. Okay, so now we have to just check one condition. If num modulus I is equal to 0 and I is equal to num divided by I, if these two conditions turns out to be true, we return true, it's a perfect square, else we return false. Because first of all, I should divide nums, which is actually a number, and if it divides, then if we divide the number with nums, it should turns out to be I again, because if we divide 16 by 4, it turns out to be 4 again. And if this condition holds true, we return true, else return false. So we can submit this and it's accepted. I hope you understand the logic very clearly. If you still have any doubts, please mention down. I have made a whole playlist on LeetCode of around 100 questions. If you want to learn more questions or have any more doubts, please mention down. Thank you for watching this video. I'll see you in the next one. Keep coding. Bye.